So here we're going to be determining a line when we are given 2 points. And you can see we have these 2 points here, 10, -1, and 5, 2. So it says determine the slope-intercept form of the equation of the line containing the points 10, -1, and 5, 2. And then we're going to graph the linear equation. Now to be able to determine the slope-intercept form, we are going to use the point-slope form to help get to here. And remember that the point-slope form is y is equal to m x minus x sub 1 plus y sub 1. But of course, in order to use this, we have to have a slope. And the equation for our slope is m is equal to, remember it's the difference of the y, so we have y sub 2 minus y sub 1 over the difference of the x's, that's x sub 2 minus x sub 1. And of course, we have our 2 points here, so we're going to use these points to help determine our slope. But before we do that, let's take a look at what the graph looks like. We can graph it, since we have the 2 points, we can graph it without actually having to come up with the equation for the line. And of course, as you see here, we have 10, -1. So if this is our origin here, I'll go 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then down 1. And there's 10, -1. And then, of course, we have 5, 2. We'll go 1, 2, 3, 4, 5, and then up to 1, 2. Because all we need is 2 points in order to be able to draw our line. So we'll put the line in. Now, if we drew it accurately enough, if you have graph paper or grid paper of some sorts, if we graphed it accurately enough, we could see if this is 10, -1 here, and this is 5, 2 here, we can see that if we come back 1, 2, 3, 4, 5, if we come back 5, and then go up 1, 2, 3, we can see that our slope is -3/5, the rise over the run. Back 5, up 3. See that? Also, we can see, if we did it accurately enough, we could see 1, 2, 3, 4, 5. Here's our intercept. So our y-intercept occurs at 5. When x is 0, y will be 5. So if that's the case, then the equation of our line and slope-intercept form would be y, that's equal to -3/5 x, that's our m, plus 5. Of course, we're also going to do it algebraically. So I'm just going to go ahead and list this as x sub 1, y sub 1, and this point x sub 2, y sub 2. Now, this doesn't have to be x sub 1, y sub 1. It could be x sub 2, y sub 2. It doesn't matter. Either way, you're going to come up with the same information. So now I could determine my slope. M is equal to y sub 2, which would be 2, minus y sub 1, which would be -1. And 2 minus -1 is 2 plus 1. And then x sub 2, that's 5, minus x sub 1, that's 10. 2 plus 1 is 3. 5 minus 10, that's -5. So there's our slope, -3/5, which we were able to determine graphically, just looking at it, observing. So now that we have our slope, we can use our point-slope form to come up with our slope-intercept form of the equation. So we'll go y, that's equal to m, which is -3/5, x minus, now you can take either one of these. It doesn't matter. Just because we designated this one x sub 1, y sub 1 doesn't necessarily mean we have to use it. We can use either one. But we'll use it anyways. Let's give it a go. So x sub 1, that's 10. plus y sub 1, that's negative 1. So then we'll go ahead, negative 3/5 x. We'll distribute negative 3/5 times x, negative 3/5 x. And negative 3/5 times negative 10, that's positive 30/5. And then, of course, minus 1. Now, 30/5, that's 6. So we have y is equal to negative 3/5 x. 30/5, that's 6. And 6 minus 1, that's 5. And look at that. This matches what we did graphically. Now, again, you don't have to use x sub 1 or this particular point. We can use this one. So let's do that. We have y is equal to negative 3/5 x minus x sub 1. And let's just say that that's this one here. So that's going to be x minus 5 plus y sub 1. That's 2. We distribute negative 3/5 times x. That's negative 3/5 x. Negative 3/5 times negative 5. The 5s are going to cancel. So we wind up having positive 3 plus 2. And of course, y is equal to negative 3/5 x plus 5. So everything seems to work out. And there we go.